Good morning. Thank you for joining. This is Tyler Lund, and I'm the Director of Sales and Marketing here at Veris Technologies. We're really glad that you chose to participate, and we're glad to see actually so many people join, and really shouldn't be surprised. We introduced this product in February and at the National Farm Machinery Show there in Louisville. We had a great response. A lot of growers and their advisors seem to have this product has grabbed their attention and their imagination, and we were excited to see how people put it to use this spring and their plans for this fall, and we're excited to share that with you here in this conversation. We have Eric Lund, the president of Veris, who's going to be answering your questions. He was involved a lot with the design and actually was out in the field in several of the states and got to see how it was working firsthand and be involved. So he'll be getting to that part of the conversation. But before we do that, I'd like to just touch on the question number one that we should be asking is why? Why use the iScan? Why even be doing this soil mapping? And the reason we're interested in that, and the reason that I'm sure you're on the call today, is because you have customers whose fields have soil variability. Well, just like in this picture with the two soils, you've got parts of the field that are sandier, siltier, and some that are heavier soils, high pH, low pH. Our soils change across the fields, whether they're flat or rolling. We and our growers have this problem. And that's the foundation of precision agriculture, right? That we have soil variability, that we want to map and manage these different soils. And for us to be able to do that, we have to be able to find out where these are in the field. And when we show these to the grower, he can see the difference. He knows that his fields have this type of variability. And the reality is his crops see the difference as well. That sandier soil dries up, runs out of water and probably nitrogen as well because it's leached out. So his crops see the difference. The inputs, they're interacting with the environment, the soil, and so we see the effect in our inputs and the way they respond in the crop. However, the only thing on the farm that doesn't see the difference in our soil properties is our sprayers, our planters, our spreaders, tillage tools, irrigation, drainage. All of the tools we put to work on the farm are blind to this variability. And that's where we come in. That's where you come in. And you say, hey, out there in that field where you have those soils, we want to be able to characterize it and find those differences. Well, a lot of the tools we try to put to work somewhat fall short. Even within a 2.5 acre or 1 hectare grid, we still have this type of soil variability. And so a lot of people have put to use a Veris map and been able to go out there and scan every 60 feet or 20 meters and find out exactly where those soils change. And when they're done with that, they don't just have another map, another layer to put in the stack. They've got the foundational soil properties, the most important physical, biological, and even the topography of the field characterized. And with that, they can begin to manage almost every input with an improved accuracy. In the past, if you wanted to have that type of accuracy in your precision ag program, you needed to use the MSP3. This is how most acres are being mapped right now, with this platform or UTV. Very helpful tools that provide very accurate and actionable maps. But when you want to cover a lot of acres, this is what we've heard from guys, is that they want to be able to do it more rapidly. And that's why we developed the iScan, to help you get over more acres and at a lower price point for your grower, and help you get your program expanded. And to talk about that, talk about how to implement it and what the nuts and bolts are, we have Eric here who's going to help us first take a look at the geography of where is the iScan running.
Hey, good morning. I'm glad to be here and visit with you. So this past spring we had our first production year of iScans. It was a limited production, but we had iScans running in these states you see here, from Colorado to Indiana and Minnesota to Missouri. We had them running in a wide variety of different soil conditions, from no-till to strip-till, conventional till, on planter toolbars and strip-till bars and field cultivator type tools. So we got a really good base of experience, and they worked out very, very well. And so we're in full production now, and looking forward to putting even more of these out. One of the things that you have to keep in mind with Verus is, as you think about Verus making the new sensors, is we didn't just start this year, last year, the year before making soil sensors. We've actually been at this over 20 years now, building various soil sensors and selling them in most every state and over 50 foreign countries. So, you know, like the insurance company slogan is, we know a thing or two because we've seen a thing or two. So this iScan is a new configuration. So obviously we wanted to do our homework, and we've actually had it in development for over 3 years. But it's not our first soil sensor. So that's one of the things that's helped us hit the ground running and really do an even better job of making sure this configuration is correct.
So, Eric, one of the questions we received, a couple of people asked, is just who is it who's scanning their field? Like what type of service provider or retailer does this fit with?
Well, actually, these pictures here show a pretty good cross section of our customer base for the iScan, but also for our other, you know, cart-based mapping type implements. Co-ops and fertilizer dealers, you know, retailers of crop inputs are buying these units, running these units out. Seed dealers, it's a great fit with seed reps and seed retailers. In fact, similar to the seed tender you see here, an iScan kind of fits the same thing. You know, your grower may not own one. The seed dealer delivers it to his farm and lets him use it for a season. So the iScan really very similar. Of course, crop consultants and agronomists, you know, they're a core of our business. They have the, you know, the agronomic expertise to really take our data and you know, put it to the greatest use. And farm equipment and then precision ag technology dealers are another very important group. And since this iScan is a piece of equipment that goes on field equipment, this last picture there on the right is probably going to be an even bigger part of the iScan going forward. What's cool about the iScan is not only do these groups use it, sell it, whatever, but there's several revenue streams that are possible with it. One is retailing these to large growers. Now these, you know, it's going to be a 3,000, 4,000, 5,000 acre grower who wants to actually buy one probably. So smaller growers and medium-sized growers can rent the unit from their local service provider, and there's also the opportunity for these service providers to actually do mapping service. And we'll talk a little bit more about that later with how the iScan fits into that service model. But there's lots of revenue streams open to Verus customers who really get after it and decide to help their growers with these soil maps.
We're going to take a look at a video, some shots from this spring showing different implements. It's a turbo till, vertical tillage. It's a strip till or strip freshener running this spring, and finally there it's on a planter. You can see the iScan mounted in between the 30-inch rows. What tools was it running on? Did you see it run on? And what do you think would be ideal for it to get mounted to?
Yeah, here's some still pictures of the videos you just saw earlier. So I think the take-home message is, as we've looked back at how the iScan performed in different situations, is we have a pretty good sense of where it will fit best. And here's a couple slides here that show it mounted in these different applications, and kind of shows the ruler there on the upper right-hand corner shows what we need is about 12 inches of space on a toolbar if it's going to be mounted on like a planter or vertical till or a planter or strip till bar or anhydrous bar. We need about 12 inches of space. We can fit from a 4x4 bar up to a 7x7. We've got a number of different mounting brackets designed up and ready to go. The other application is to mount it on the side of a field cultivator or vertical till, something where you don't necessarily have this big toolbar that all the row units are mounting to like a planter, but you can attach it to the side, and that's the picture in the lower left-hand corner. We fit those from a 3x5 frame to a 4x6 frame. So a pretty good range of different applications that it'll fit. If we think about what conditions it fits best in, what operations, and this is somewhat just kind of in order, I guess, of preference maybe. Planting is great. It's a smooth seedbed type condition. Field is moist. It's just great to do it at planting time. Secondary tillage or seed bed prep, like on the vertical till or a field cultivator, that's another good time. Vertical tillage, of about any time you want to do vertical till, it's good. Then strip till and NH3, depending on the conditions of that strip till. And I'll just explain what I mean there about why that's a little more, you have to be a little more careful about how it would work on strip till and NH3. So the field conditions to avoid, or field conditions to just be aware of that you may or may not get as good a data as you'd like. One of those would be extremely heavy residue, kind of windrowed by the strip till or planter row cleaners. There on the lower right-hand corner, you see just a real windrow of corn stalks. Probably that's probably right after harvest. It's probably not going to be ideal for the iScan to try to navigate between those strips in that condition. What's interesting is right above that is a picture of spring strip till, and the iScan worked great in those conditions. So you can kind of see just what the difference between fresh corn stalks and then overwintered corn stalks are. Primary tillage, I think, when we say primary tillage, that means a lot of different things to a lot of people. Some people have, leveling attachments on their primary tillage, and so there's sometimes primary tillage will be okay, and sometimes it's a bunch of slabs rolled out by a moldboard plow or a chisel plow with wet conditions, and of course the guy wouldn't want that iScan trying to bounce over those clods and collect data. So that kind of gives you some idea of where we see it fitting really well, and then just area where you might want to be concerned. I think the good thing is there's a lot of areas, a lot of operations where it fits very, very well. In the rare, and this is another question that came in, is does it interfere with normal field operations? And well, as you can see here, very rarely an unlock position is provided. So if you get in a condition like one of those where it's just not ideal, you can lock it up and keep going. All through our development process of this, we've known that growers have got their main job is to do their planting or tilling or whatever they're doing, and collecting data is secondary. So we've part of our design criteria has been to make sure it does not interfere. And the neat thing about having this mounted between planter row units or on the side of a field cultivator is we're not attaching some sensor to a field cultivator shank or a planter row unit where there's that device has another job, and so we don't put you in a position of trying to compromise between, well, do I set it right for my data operation or for my field operation? But by being a separate device, you don't have to make those choices and those compromises.
Another question that was asked, and a very valid one, is how does it mount? What type of process do you go through? And the response has been very positive to the way we mount and the simplicity. We'll just check out a quick video that shows an overview of it. Really, the first step is installing a bracket with 2 U-bolts, and you're able to lower the iScan down onto it. Very easily self-aligns for the bolts. And while we're cutting from scene to scene, this whole operation was filmed with 1 drone battery, so that gives you an idea of just how long it takes. Install the electronics, and that's the entire process.
One of the most positive comments from virtually everybody that got one of these this spring has been how easily it installed, and they've been very pleased with how easy it is to put on. So another question is, how is it powered? Where does it get the GPS? Basically, how many cables do I have to zip tie to the frame is kind of I think the question. So basically, we've made this as self-contained as it possibly can be. So we need 12-volt power from the tractor, and so that if you don't use the lithium-ion battery pack, that is an option. You do have to string a cable to get 12-volt power, either somewhere back on the toolbar to the tractor. The vSense controller has an internal GPS and Bluetooth connectivity to the tablet PC, so you don't have to string any cables to make it work. You can incorporate the tractor's RTK signal, or the RTK coming from your auto steer, if you want really accurate elevation maps, and then you would be bringing that back through a serial cable. The maps are displayed in a program called Soil Viewer, as you can see there on the right, and they're displayed in real time. One of the kind of surprising things that I think people have been kind of amazed at is how much growers are enjoying looking at their soil map. You know, with auto steer now, you guys can spend time looking at some of their displays a little more than they used to, and they've really been kind of buying into the idea of watching their soil map appear in front of their eyes, and really it's heightened some of their interest in. So that's why the yield map always showed that spot in the southwest corner kind of a thing, and so that's been a real positive comment.
Again, there on the right is the map in real time that you can see as you're going across the field. But the output is one of the questions. Folks wanted to know what data type or what file format does the data come in.
Yeah, so this is kind of for the data hounds on the call, which I think there are a few. The final output is a text or shape file, very common file formats for various GIS systems. The data gets sent to the Veris cloud. The cloud called Field Fusion is our portal, and so it's reviewed by the Veris data team, and a report is provided to the service provider. This is a critical step for ensuring data quality. If soil sample data is available, and it can be legacy grid sample data, we'll calibrate the sensors to lab properties, or the separate samples can be taken for this. We do recommend calibrating the sensors to lab data if possible. And finally, topographic features are extracted from the elevation data, which are slope and curvature, which are very important features to include with the soil data. One thing to keep in mind about this is in our cloud-based software, it's basically 3 clicks to write a prescription. So once you get the data in there and calibrated, basically you can develop management zones and write your prescriptions very, very rapidly. There's also API and data upload capabilities to various platforms. And here's some examples of those. We have an API with Climate Field View, and others are in process, and the data is compatible with basically virtually all the GIS platforms that are out there on the market.
Another question that came in is just the basics of how do the sensors work to measure electrical conductivity and organic matter.
So one of the things we did here is we figured out with EC how to do this in a narrow configuration that would fit between rows on a planter. So it's kind of an inline design. So we're injecting electrical current with the front coulter and the rear closing wheels. Those are the injecting points, and then we're measuring the voltage drop in the middle here with the 2 members you see kind of buried there in the middle, right here. So that's how we do electrical conductivity in a narrow configuration. The power of electrical conductivity is that it really correlates very well with soil texture. The finer the soil particles, like clay, the more it conducts. And so it's a great way to run a device across a field and map soil texture and salinity. If salinity is one of the driving factors in a field, then it'll detect salinity. But it's a great soil texture map. Of course, soil texture, the key things for soil texture relates to water and nutrient holding capacity. It's probably the single most important factor in a farm field is its soil texture. Whether it's a silt loam or a clay loam or a sand loam or whatever the soil is, soil texture is extremely critical. Organic matter, we do organic matter with an optical window running down in the soil, shining an infrared and red light down into the soil and measuring soil reflectance. Basically, it works under the principle that darker soils have more organic matter than lighter colored soils, and we measure below the surface in order to ensure that reading really relates to organic matter and not crop residue or soil moisture. The nice thing about the iScan is it's a very stable platform, so we have very good soil contact and a self-cleaning action on the window, and we get that because it's a very robust platform. There's a shot underneath looking up at that metalware plate. Organic matter is another very important soil property, relates to water holding capacity, nutrient holding, but also nutrient mineralization. So a lot of the new nitrogen mineralization software packages out there, like Encirca from Pioneer and the Climate Field View and the AdaptN and others that are coming, really want to have organic matter mapped precisely because it'll directly affect 20 to 40 pounds per percent organic matter based on the differences in organic matter in the field. So it's a very critical property to map.
One of the next questions was, What did the tractor driver, the person running the planter, have to do kind of on a daily, weekly basis?
So as we said earlier, one of the key things we've had in our mind is we don't want the tractor operator to dink with it at all. We want him to be able to just concentrate on his job of planting or whatever. So basically he has to be able to create the file in Soil Viewer and name the file appropriately. He may have to adjust the depth of the unit as he changes from one field to another if there's different field conditions. And just observe the map, and if something's not showing up, just investigate. And then at the end of the day, power the unit down so he doesn't drain the tractor or the battery. The key thing is that we found this spring is it just worked. Guys did not have to dink with it, and it didn't require a lot of attention. It got guys turn it on, they mapped their field. At the end of the day, they had several fields worth of data, and it really did not require much attention. Then weekly, if a guy's running it for a long period of time, you might get into some wear items and lubrication, and adjusting the air pressure, and the down pressure airbag is needed if it bleeds off. But very minimal amount of work a guy has to do. Of course, the next question then is, what does the retailer or the consultant, whoever's providing the iScan to the grower, what does he have to do? And so, number one, install it. Provide some basic instructions on how to set it in case he gets into some soft ground or hard ground. Just like a planter, there might be some adjustments he has to do. And then kind of get it set up. Adjust the settings on the first field. Set the air pressure accordingly. And then on a frequent basis, submit the data to Field Fusion, lubricate and repair items as needed. Very typical amount of support that a guy would have to do on something you're renting out to a grower. And I think we've made it fairly clear on this, but a lot of this is geared to renting this out to growers. Because this is a one-time map, that's how a lot of this is going. That's why we've made it easy to install. That's why we've made it fairly easy for the operator to run it without having to worry about it, because this is kind of you put it on, you map your field, you take it off, and you're done, because these are long-term soil properties.
These are long-term soil properties, but are we mapping it well? Are these accurate soil maps? That's one of the questions. And I just threw up a couple that were done this spring, and it really does. If you look at the USDA soil survey overlays, you can just see the additional precision that you get by adding this to your planter. The one on the left I was actually involved with, and the grower, he didn't have any precision ag equipment, variable rate technology on his planter. This was his kind of first foray into precision ag, and he was really impressed with the precision. So not only are they accurate when we take lab properties and the correlation coefficients, but when he saw it, he recognized the map. It looked like a farm he knew. He just never had it digitized before. And so the results were stark in terms of the added precision, but also just how it got the growers excited and involved. Another question comes, well, how do they compare to other various platforms in terms of accuracy?
And as I said earlier, we've got the advantage of having been in this business for a while and having other platforms that do this kind of mapping in a more of a tractor implement or UTV style. So we're able to compare the iScan to these, and we did not put this on the market until we were confident that we had very comparable data quality. And you can see here, if you look close, both at the raw data maps on the left, and then once they're contoured out into more zones that you would actually put prescriptions in, the maps are highly correlated. That kind of brings up a question that we want to address that has come up from various people we've talked to, and the questions that were submitted for the webinar, and that's, how does this iScan fit with other various platforms? Why would I want one versus the other, and how do they compare, not just in data quality, but kind of in a business model kind of approach? So we have a number of customers who are being very successful using what we call the cart approach. So these are, you make a special trip across the field that's dedicated to collecting soil data. You can use a tractor, you can use a UTV, you can use a four-wheel drive pickup truck, but it's a dedicated pass. So where does this fit? And does this iScan replace all this? And to that we say emphatically, no, this is still a great way to collect data. So just a couple things to keep in mind is typically the charges when a customer does this cart-based mapping is, it's a $10 to $20 per acre charge. Of course, that's up to the customers to choose. But considering that these are long-term soil properties, that's really not an excessive charge to apply. These other sensor carts have a dense pH map capability, so you can get this other soil property mapped really well. And one of the things that we've seen with this approach is that when a service provider dedicates a vehicle to it and a man, and he basically goes out, or she goes out and covers the acres whenever they can. In other words, when the sun's up and the field's ready, they've got somebody ready to go. They can cover 10 to 20,000 acres per year with a machine, because they're not stopping to, like you would with a planter that's got an iScan on it. They're not stopping to fill the planter. You're not limited to a narrow window of whenever the field's being worked. You can go out and map anytime. So you can really cover a lot of acres with these carts. And we have customers doing it, and we'll continue to be in this business. What we've seen, though, is that a lot of our customers have told us, I just don't have time during this busy spring and fall season to dedicate a person to it. I've got too many other things to deliver, seed and fertilizer and whatever. So I need some way from I need some way to scale up and get more data in, and that's really where the iScans come up. So we developed the iScan really for convenience and scalability. Number one, that was it, probably more than the second one up there, the saving dollar. But growers and their precision providers wanted the data, but they didn't feel capable of really dedicating the manpower to it during the busy season. The second item there has really been kind of a surprise to us, that as our customers have bought these, they've said, I was able, some of our customers that have bought these have been doing cart-based mapping, and they've augmented their efforts with the iScan. They've told us, my larger growers, I maybe did 200, 300, 400 acres for these large growers, but I just couldn't get them to map their whole farm. That 5,000 acres at $10 an acre is a big check for data, for zeros and ones, when you compare to what else you can buy for $50,000. So they were looking for a way just to get the mapping costs lowered, and so that's where the uptake on this from some of the larger growers has really been very, very surprising and pleasing. So that's kind of how it fits, and hopefully that'll be helpful to you as you think about how this might fit into your business.
One of the things that's in common between both the MSP3, the U3, and the iScan is that both those platforms they're measuring EC and organic matter. And that's one of the questions that came through. Is it important to measure both of them? Do we need both these maps on our farm?
I think this slide here of this Illinois field will help answer that question. So some fields, and as this is the case in this field, there's areas that have high conductivity, as you can see on the map on the left where the blue circle is, that also have higher organic matter. So it's a heavy black clay as you look in that picture in the upper left-hand corner. This field also has areas of high conductivity, of heavy clay texture, that appear to be similar to where the blue circle is, but when you look where the red circle is in the organic matter, it has low organic matter. So if you look at the picture there in the left side of the screen, you can see heavy clay but low organic matter. This field also has areas of low organic matter that are more silty, and areas of silty soil that are higher in organic matter. So if you think for a minute, if all we had was an EC map, a soil texture map, we would, in this case, if you were doing this mapping for a customer, you would give them an EC map, and you would say these two soils are the same, because the EC map could not tell the difference between those two. You would also be telling him these two soils are the same, because if you look at the green and the yellow, basically those are the same conductivity. Likewise, if all you had was an optical sensor measuring organic matter, you would say these two soils are the same, because optically, as you can see here, they are. They both are low organic matter. And you would be saying that this nice rich loam is the same soil as this heavy clay, because optically they are very similar. So this is why we need both sensors, because if all you had was one, you really would not be managing the field appropriately. It wouldn't even be actually close to managing it appropriately. It wouldn't be a minor problem. Could be a fairly significant difference in mineralization potential, in water holding capacity that you'd be missing by only having one sensor. Of course, with all this data and all these sensors, you need a way to understand it better. So here are the kind of way we've described the soils, and kind of a blue, red, yellow, green type soil. And we then, in our Field Fusion software, we actually can combine and fuse these maps into one map ready for prescriptions, to where you can apply the right rate of seed to each one of those different soil combinations.
Now that you've been able to map EC and organic matter, one of the questions folks have is, can we just go directly from the sensor to a prescription? Can we use real-time control?
There's really no technology limitation. Verus can output real-time OM and CEC estimations. There's really no technology limitation, but we do believe there's some significant agronomic limitations, or things that are not fully optimized when you do this. And one of those is grower and consultant input. Many of the people on this call are consultants who will be providing seed and other precision advice and agronomic advice. When you do it in real time, there really isn't the possibility for doing that like there is when you can sit down with the map with the grower and talk about what's the best hybrid to put on different soils, the best rates. And as I mentioned in the previous question, it's important to use both OM and CEC data, and we believe it's important to use calibrated and validated, where you're not just letting a sensor tell you what to do, but you're actually validating that everything's working well and it's been calibrated directly to a soil property with lab data. And finally, probably in some ways one of the most important things to consider is soil texture and organic matter change very slowly over time. These maps will be good for many, many years, perhaps even that standard 40 planting seasons that we all talk as growers that we'll have. So we believe that the best approach is to map it well one time with a high quality, validated, calibrated map, and let the map drive the prescription. Let the prescription be in the controller, not trying to do it from some kind of sensor. And finally, the Verus iScan versatility, because you can put this on strip till bars and other tillage passes ahead of planting. If a grower finds himself with maybe a field he just picked up and he didn't have time to collect a lot of data, he can still collect the Verus iScan data on a different application, different operation before he gets to his planting operation. He doesn't have to just do it on the planter. So that's kind of our I guess our philosophy or approach as to why it's important to use the maps and not pursue the real-time control approach. There are obviously soil properties that you may want to do real-time control. Obviously the airbag down pressure and those kind of things where things that change season to season within the field makes a lot of sense to do real-time control. We're just saying that for these soil properties and for seed prescriptions based on these soil properties, we don't believe real-time control is the optimal approach.
And as you mentioned the iScan versatility, I guess it's a good segue into where does the iScan cart fit into the picture? How does this help growers and advisors get over the acres?
Yeah, so when we brought this iScan onto the market, we really were focusing on the implement side of it. But as we have put this on the market, we've understood that there's a great opportunity to be able to pluck this off of a toolbar or an implement, a field cultivator, whatever, and put it on a cart and be able to map with it as a kind of a cart-based approach. So as you can see this picture here, it widens the mapping window. It's a great way to do demonstration maps. I mean, you're not going to put an iScan on a 24-row planter for a demonstration. So if you want to demonstrate the ECOM data to a new customer, it's a great way to do that. It can be pulled with a UTV or an ATV. Great for smaller acreage growers. A 200-acre corn farmer with a 6-row planter probably it's not going to pay you to go out and put the iScan on his planter for that small an operation. So the cart makes a lot of sense. Rental and custom, so some of our customers are doing custom mapping with these. Others are actually having the grower bring in his own UTV and doing the work himself. It also allows for some in-crop mapping. We've spaced all the soil engaging components and wheels so that you can do some in-crop mapping. And I think we've got some video just of the cart operating here. You can scoot right along with it. 8, 10, 12 miles an hour is like most of our carts. You can go that fast. Here's one of the customers rented a tractor to do some in-crop mapping with the iScan. Here's kind of a cool little GoPro video showing how the in-crop mapping works without hurting the corn that's growing.
Whether folks are using the iScan cart or they're putting this on their customers' planters or tillage tools, what are the economics? What's the payback an iScan provider can anticipate?
Let me show you some numbers that are really reflective of what's possible with the iScan. This model I'm going to show is a rental business model only. There are different other revenue streams we'll talk about in a minute, but in this example, grower number 1 rents the iScan, puts it on a 24-row planter. In this case, he planted 3,000 acres, and so that's gross revenue of $15,000 from that operation. That's at a $5 per acre rental charge. Now, we're not saying that's the recommended rate, but we think it's somewhere in the ballpark of where these will be rented out. Then after that grower is done with it, another grower comes in and rents the iScan cart, and he maps 2,000 acres on his own with his UTV in standing crop. And it's interesting that these are actual acres that happened with one of our customers this spring who rented the iScan for these applications. So these are real acreage numbers. Now in the fall, there's still business opportunity left. So if they can rent the unit out for 2,000 more acres, so that's a total of 7,000 acres being mapped in a year with the iScan and a gross revenue of $35,000. Now the exact cost of the iScan will depend on which model and options and everything you get, but $20,000 is definitely comfortably equipped, and then some for the iScan. So more than pays for it in the first year. Other revenue streams that can be generated by this, in addition to the rental, are retail. Retailing these to large growers who will just leave it on their planter and map all the acres that they're farming. Custom application mapping. One of our customers plans to mount this on an NH3 toolbar and just map every acre he covers this fall with the NH3 bar. He'll also get data, and of course the cart mapping, whether it's for demonstrations or just using the cart as a custom mapping option. There's definitely some revenue that can be generated from that. So there's a number of ways that revenue can come about by using the iScan. But the key and most important revenue stream is really the prescriptions that are going to come from this. In this example on this page, 7,000 acres. These are additional acres that are in your precision program. And one of the things we've seen with Veris equipment over the course of the last couple of decades is that there's a great amount of loyalty that comes from the grower towards the service provider that enabled him to get these high quality soil maps. While some shopping around for fertilizer prices and those kind of things happen, when you make a good soil map for a customer, that data and those maps tend to stay in the precision program better than some of the other things that are out there. Let's look a minute at what the economics are for the grower. Obviously, we have to make the grower money, or we're not going to make any money ourselves. So in this example, from this spring, a custom charge per acre for an ECOM map is about $10 per acre. So had these two growers not mapped with their iScan cart, they would have paid about $10 an acre. So by using the iScan, the guy with the 24-row planter saved about $15,000, and the grower with the iScan cart saved about $10,000. So those are some significant amounts of money that are in those guys' bank accounts today that wouldn't be there had they done it commercially. So there's definitely some very good economic paybacks for the grower as well as for the service provider or the iScan provider. It's definitely a win-win situation for both parties.
And this last question summarizes kind of a lot of the questions that different participants asked, what are the benefits? Why should I implement this product in my program? And what we've covered already is it just allows you to get over more acres. The goal with a lot of service providers is not to just make a lot of money on a few acres, but we want to establish, grow their program, and this allows them to do it at a lower price point so they can really scale up. And because of that, it allows you to get your other input, the input that you're trying to do a better job of delivering by using that soil map. So your seed, your fertilizer, your program, or even your equipment, allow it to get on more acres faster. And with this tool, we're not just collecting one data layer, we're collecting both of these major water holding capacity, nitrogen, mineralization properties, and at a very high resolution. It makes it a very profitable pass across the field. And also, this platform is flexible, really allows you to get on different toolbars, tools that are going across the field. Every year that farmer plants, every year that farmer tills or applies fertilizer. So it's going to get across, the mapping is going to get done, and you have the opportunity to attach yourself and some income to those passes that are taking place, and at different times of the year. And really, there's no requirement by that grower to have a certain type of planter or previous equipment added to it. It's colorblind. Really allows people that are advanced or beginners in precision ag to be able to get this data set. And once you collect that data, you can do what you want with it. You can make it, you can add your own input and advice with it. You can put it into a different software platform. It's really up to you to make use of to help that grower. And the other advantage is it's based on a platform that's been used for over 20 years, and now it's in a configuration that's been out across several major production corn belt states, and it's ready right now and available to be put to use this fall, this spring. Guys are already getting equipped and ready. And so then lastly, the main benefit is that it helps you and your growers see the difference in their soil. That you can identify where these changes happen and not have any mistakes in your seeding prescription, your nitrogen program. You really can define where these differences happen. If we've glossed over anything, please don't hesitate to give us a call. Here's my phone number, my email address. Shoot us a question. If you'd like to find out more information about how you can provide this solution for your growers on all their acres this fall, we'd love to be in touch with you. Thanks again for participating.